Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Abdul Azim bin Wan Muhammad Fauzi. Today I want to present the poster from my PSM2 that the title is the development of footstep power generation system using piezoelectric sensor. So my supervisor name is Dr. Farida Hanim binti Muhammad Noor. And firstly, I go through to the abstract. Some of the present system flaws have been recommended to be fixed in this project. The improvement have been created in several ways for power harvesting device to be used in a practical application to supply the power demand. And the function of piezoelectric crystal is to produce electric output from human motion in the surrounding environment. Since of their crystalline structure, piezoelectric material may transform from the mechanical energy to the electrical energy. Uh, and then this material can collect mechanical force from human motion, mainly ambient vibration, and it will convert it into electrical energy that may be utilized to power other device like mobile phones. So because it's not feasible to charge 12-volt battery through the crystal output, the electrical energy produced by the piezoelectric crystal is relatively low in the region of 2 to 3 volts, and it will store in a 2-volt battery through the charge controller. Then we use the boost converter used to raise the voltage. The purpose of boost converter is to raise the level of voltage that is stored in 12-volt battery. The buck converter circuit is used to reduce the voltage from 12-volt battery for the microcontroller supply. And then this project may apply in highly populated locations such as walkways, staircase, and other area where normal people will pass through to there. So the LCD will show the voltage output that be measured by the piezoelectric sensor. So we go to the introduction. We have three segments: problem statement, objective, and study of, scope of study. So for the problem statement, electricity is widely utilized energy source that is growing in a popularity as the population grows. The squandered energy must be used to create the energy electricity, and the unknown approach is utilized for the variation of the pressure in the ground caused by the passing of exposed individual or vehicles, resulting in constant pressure amplitude. And the last point is with the rising depletion of fossil fuels and non-renewable energy, there is an urgent need for another source of energy to replace the depletion and continually supply the increasing energy demand. So, our objective is to investigate the energy harvesting process of a piezoelectric device to develop a footstep power generation system using piezoelectric sensor, and then to verify the performance of the developed footstep power generation system via experimental setup. So, scope of studies. This project will develop a piezoelectric energy harvester. This project used the bridge rectifier to convert AC to DC, and then we use microcontroller Arduino Uno to display piezoelectric voltage from the piezoelectric dials, and then LCD will connected through to the Arduino to display the voltage. This project will generate energy from piezoelectric material and store it in a 12-volt AC battery. Boost circuit will boost the piezoelectric voltage. So this project piezoelectric material must be mechanically stressed to create energy. So we choose for the human step to give the energy, and then the battery store energy. The produced energy will store in this battery and will supply to the DC load such as a mobile phone. So for the literature, is the accumulation of electric charge in reaction to mechanical force, or linear electromechanical interaction in a crystalline material that lacks inversion symmetry, then the direct piezoelectric effect can be reversed to create a mechanical strain by providing an electrical charge. One type of ferroelectric material is a ceramic that have piezoelectric properties. Ferroelectric material are polar crystal that can work even without an electric field from the outside. PZT are linked together in a series to find out which kind of connection give off the most voltage and current. So I go through to the methodology for this project. So this is a flow chart. So we start and power supply on the Arduino. Initialize of display, and then we apply the mechanical pressure on the piezoelectric tiles, and then it will convert mechanical energy into the electric energy, and then the display, the LCD will display the voltage, and then the convert AC to DC using the bridge rectifier, and then supply through to the 12-volt battery, and so this is the figure when this is a piezoelectric tiles. The human step up on it and it will create the energy. Then this is a project hardware. This is the piezoelectric tiles. The combination of 20 piezoelectric sensor that connected in series. That is the electronic box that suit the LCD and USB, and then the other electronic equipment. Then this the charging of phone to the 5-volt USB, and then the LCD will shows the voltage that produced by the piezoelectric tiles. So this is a result and discussion. We can conclude that the less step for the person, the low it will be low the voltage that produced by the piezoelectric tiles. So we can see that the higher voltage is a 3.44 volt at the 60 step to get 3.44 volt. The human weight 85 kgs. And then this is a graph voltage gain based on the footstep and weight. We can see the blue graph for the 60 step, and then the higher is the 85 kg weight of the persons. So for the conclusion, the project has been implemented, tested and proved successful. It has low startup ongoing cost, and it's a cost-effective power source. Almost all of the world population has access to a cheap power. This project is useful in distant areas with minimal electricity. Low piezoelectric tiles output less than 5 volt. To increase the voltage, we use a buck converter to boost up the input voltage. So the project will drive the DC load. The force applied to the piezoelectric sensor plate can drive AC and DC loads, helping regulate the energy. From this experiment, Christian have been encouraging thus far. So for the recommended, the better piezoelectric crystal and better location selection in the area of electronic means that more power can be created from this piezoelectric sensor. So, and it may be seen as the next auspicious source of producing energy because of the improvement in this sector. Okay, that's all from my presentation. Thank you for the watching.
Okay, Assalamualaikum. Hari ini saya akan membuat demo untuk projek hardware untuk tajuk saya. Okay, ini adalah piezo tiles elektrik. Okay, dia ada 20 sensor dan saya menggunakan kabus ni untuk memberi dia vibration apabila kita tekan. Seperti yang kita tahu, untuk piezo ni dia akan apabila dia vibrate ataupun ada tekanan, dia akan memberi elektrik lah. Okey, untuk ini adalah panel box. Dia ada LCD dan membaca voltage yang terasa daripada ni. Dan ini adalah USB. Okey, saya tunjuk dia punya elektronik. Okey, kat sini adalah ada Arduino dan ini adalah bridge rectifier. Dia akan masukkan kepada sini dan akan keluar kepada ni adalah boost converter untuk step upkan voltage dan terus direct kepada bateri. Dan ini adalah buck converter. Dia akan step downkan 12 volt kepada 5 volt untuk supplykan kepada bateri, supply kepada Arduino. Dan ini adalah voltage sensor yang akan membaca voltage yang terasa daripada PIEZO ni lah. Okey, balik. Okey, sini ada switch on off. Okey, untuk ni, okey, voltage apabila seseorang pijak. Okey, inilah voltage yang terasa. Okey, untuk USB ni kita boleh guna untuk DC load. Saya menggunakan handphone untuk charge. Okey, apabila kita connectkan, kita onkan switch ni untuk transfer untuk charge bateri. Okey, dia akan charge. Okey, ini adalah voltage untuk bateri, 12 volt bateri. Okey, itu saja daripada saya. Sekian, terima kasih.